Hello students. So today I am doing class for class 12. The topic is limit, that is from the calculus portion. Okay, so actually you did limit in class 11. So let us discuss again the limit chapter, because in class 12 you have to do continuity and differentiability, and for this continuity and differentiability you should know the concept of limit. So I am again revising it. Okay, so you have already done in class 11. So let us revise it again. So what is my limit? हामीले लिमिटलाई नेपालीबाट भन्छ हामी सीमा अथवा सीमित भनेर भन्छौं. ठीक छ? त यो म्याथमेटिकली लिमिटलाई हामी कसरी लेख्छौं भन्दाखेरि LIM लेख्छौं कि त हामी LT गरेर लेख्छौं. So limit mathematically it can be written as LIM or LT. Whenever I say limit, you have to write LIM or LT. So this is the mathematical notation of limit. So what is the concept of limit now? So let us write down a function here. You know the meaning of function, isn't it? So y is equal to f of x. So y is equal to f of x. Y is equal to f of x. So depending upon the real values of x, you can get a definite and unique value of y. Okay? So x को value हामी यहाँ जति पनि हाल्न सक्छौं, जे पनि हाल्न सक्छौं, x को real values जति पनि हाल्न सक्छौं. So depending upon the value of x, you can get the value of y. So here the value of x is the independent variable and y is a dependent variable, because y, the value of y depends upon the value of x. So depending upon the real values of x, if you can get the definite and unique value of y, then y is said to be a function of x. Or any expression in terms of x is known as a function of x. Okay, so now let us take an example of a function. Suppose if you have f of x is equal to x square minus 1 divided by x minus 1. Okay, so you can give any values of x out here, any real values of x. Suppose if you put x is equal to 1, so putting x is equal to 1, so what do we get? That is f of 1 is equal to 1 square minus 1 divided by 1 minus 1, which is equal to, this will be 0 by 0. So something divided by 0 is always undefined. It is always undefined. So division by 0 is meaningless. So 0 by 0 is undefined and it is known as indeterminate form. Indeterminate form. Indeterminate form. So in this case, while putting x is equal to 1, f of 1 is equal to 1 square minus 1 divided by 1 minus 1, which is equal to 0 by 0, which is always undefined, because something divided by 0 is meaningless. So denominator cannot be 0. This is known as undefined and it is known as indeterminate form. Okay, which is undefined. Okay. So now in this case, this function f of x is undefined when x is equal to 1. The function, in this case, the function f of x is undefined. The function f of x is undefined when x is equal to 1. Right? Here the function f of x is undefined when x is equal to 1. But if you give any values of x other than 1, then you will get defined value of f of x, because in the denominator there is x minus 1. If you put x is equal to 1, then 1 minus 1 is always 0. So something divided by 0 is meaningless. So this function f of x is undefined only when x is equal to 1. So other than 1, if you give any values of x, then function f of x is defined. Okay, that is, now The function f of x is defined when x not equal to 1, isn't it? That is, the function f of x is defined. The function f of x is defined when x not equal to 1. The function f of x is defined when x not equal to 1. Okay, that means this function f of x is defined when x not equal to 1, means it may be x greater than 1 or it may be x less than 1. The function f of x is defined when x greater than 1. You can give any values of x greater than 1, or you can put any values of x which is less than 1. Okay, now we'll discuss about this term. So how is it read? It is read as x tends to 1 or x approaches 1. It is read as what? It is read as x tends to 1 or x approaches 1, but x not exactly equal to 1 in this case. X tends to 1. X is nearer to 1. X tends to 1 or x approaches 1 or x is nearer to 1. Okay, that is, x is approaching nearer to 1. Okay, now in this case we take limit x tends to 1, because in this case when you put x is equal to 1, the function f of x is undefined. So that's why we are taking limit x tends to 1. Okay, x tends to 1 means x exactly not equal to 1, but it is approaching towards 1. So x is approaching towards 1 means either it is approaching towards 1. Suppose this is a number line. Okay, suppose this is a number line, right? Suppose this point is x is exactly equal to 1. So x is approaching towards 1 from the left hand side or from the right hand side. X is approaching towards 1. This is your left hand side and this is your right hand side. So on the right hand side all the values of x are greater than 1. You know that is x is equal to 2, x is equal to 3, x is equal to 4, and so on. There are infinite number of values of x greater than 1, isn't it? It goes up to plus infinity, right? And on the left of x is equal to 1, it may be x is equal to 0, x is equal to minus 1, x is equal to minus 2. It goes up to minus infinity. So x is approaching towards 1 means x is going nearer and nearer to 1, either from the left hand side or from the right hand side. Okay, so limit x tends to 1 means x is approaching towards 1 either from the left hand side or from the right hand side, but x is not exactly equal to 1. Is that clear? So now limit x tends to 1 f of x. So which is equal to limit x tends to 1. So I think you have understood the this meaning of limit x tends to 1, because in this function when you put x exactly equal to 1, this function f of x is undefined. That is, we are getting 0 by 0, which is meaningless and it is known as indeterminate form. Okay, so now in order to get the defined value of the function f of x, we take limit x tends to 1 f of x, which is equal to limit x tends to 1. What is the value for f of x? What is the function of x here? It is x square minus 1 divided by x minus 1, right? So which is equal to limit x tends to 1. So you can factorize the numerator. So how can you factorize the numerator? It is x plus 1 into x minus 1 divided by x minus 1. So here you can cancel this x minus 1. Because of this x minus 1, because of this x minus 1 we were getting undefined term, isn't it? So that undefined term, that is x minus 1, is cancelled out here. So which is equal to limit x tends to 1, and within bracket what do we get? X plus 1. Okay, now how can you find out the value of this x plus 1 now, right? So now you should know the concept of limit. Okay, now you should know the concept of limit from this case, from limit x to 1, limit x tends to 1, x plus 1. What is its meaning now? Okay, now x is not exactly equal to 1 in this case. It is read as x tends to 1 or x approaches 1, and so x is going nearer and nearer to 1, but x exactly not equal to 1 in this case. So how can you get the value of this limit? Okay, so now suppose you make a table out here. Okay, so we are making a table out here. Suppose this is f of x. Okay, suppose this is x, suppose this is x. Okay, now what is the value for f of x out here? It is x plus 1. So this is your f of x. Actually in this case f of x is simplified, isn't it? In this case f of x, function of x, is simplified here, and we got what? We got x plus 1 out here. Okay, so now x is approaching towards 1. X is going nearer and nearer to 1, either from the left hand side or from the right hand side. Okay, now let us take on the left hand side. Okay, so let us take on the left hand side. So suppose this is x is equal to 1. Suppose x is approaching towards 1 from the left hand side. So let us take this value as 0.9. You know that 0.9 is less than 1, isn't it? You can take 0.9. So if you write 0.9, but x exactly not equal to 1, so we can take x is equal to 0.9. If you put x is equal to 0.9 out here, what is the value for x plus 1? What is 0.9 plus 1? What is 0.9 plus 1? It is 1.9. Okay, so again you approach towards 1. We can write 0.99, isn't it? Again we are approaching towards 1 if you write 0.99. So 0.99 is slightly greater than 0.9. That means we are approaching towards 1. Okay, so if you put 0.99, so if you put 0.99, what do we get? What do we get? 0.99 plus 1, it is 1.99. Again if you write 0.999, what do we get? 1.999. 0.99 means again we are approaching towards 1. Okay, so we can have any number of values like 0.999. After decimal point there will be 4 nines. After decimal point there will be 5 nines, and so on. So if you put 0.9999999, something like that, so what do we get? 1.9999999, etc. So after decimal point, how many nines are there? 7 nines. So x plus 1, what is this value? It will be 1 point. How many nines will be there? 7 nines will be there. Is that clear now? Now in this case, now 0.999999 means it tends towards what? 1. It tends towards what? 1, isn't it? 0.999999 means it is approximately, this value is equal to 1. So this is not the exact value, that is 1. So this is known as the limiting value. This one is known as the limiting value. And 1 point, how many nines are there? 7 nines. That means it almost tends to what? It almost tends to what? 2. Okay, so we can write here is equal to when limit x tends to 1, x plus 1 tends to what? 2. So when x tends to 1, so when this x tends to 1, then f of x tends to 2, isn't it? That is, when x tends to 1, f of x tends to 2. Is that clear? So here we can write, when limit x tends to 1, x plus 1 tends to what? 2. But 2 is not the exact value of this function f of x. 2 is not the exact value of this limit. 2 is known as the limiting value of this function f of x. Is that clear to all of you? So in this case, we were approaching towards x is equal to 1 from which side? From the left hand side. हामी x is equal to 1 पट्टि गयो from which side? From the left hand side. अब हामी कहाँबाट जान्छौँ? Right hand side बाट जान्छौँ. So on the right hand side, all the values of x are more than 1, isn't it? Now we are approaching towards x is equal to 1 from which side? From the right hand side. Okay? Now let us take here x, and this is your f of x. So here also x tends to 1 means x exactly not equal to 1. Now we are approaching, now x is approaching towards 1 from which side? From the right hand side. From the right hand side means we can take here 1.1, right? So if you write 1.1 here, if you write x is equal to 1.1, if you put 1.1 here, what is 1.1 plus 1? That is 2.1. This is your 2.1. Again, अझै हामी x is equal to 1 को छेउतिर जान्छौँ. अझै हामी x is equal to 1 को छेउतिर जान्छौँ. त यहाँ के लिन्छ अब 1.01. 1.01 is less than 1.1. That is, again we are approaching nearer and nearer to x is equal to 1. Okay, so let us write here 1.01. That means we are approaching towards 1. So if we put 1.01 out here, x is tending towards 1 from the right hand side. So if we put x is equal to 1.01, what do we get? 1.01 plus 1, what is it? 2.01, right? Again you can put 1.001. Again we are approaching nearer and nearer to 1. Okay, so now if you put x is equal to 1.001 plus 1, what is the result? 2.001. Similarly, we can have any number of values of x there, like 1.0001, 1.4 zeros and 1, like that. So if you have 1.000000 and 1, so 1 point after decimal point, how many zeros are there? 6 zeros and 1. So if you put x is equal to 1.6 zeros and 1, what is the value of this limit? You will get 2.000000. That is 6 zeros will be there, and you will write 1 out here. Okay, that means when you have 1.00000001, something like that, it almost tends to what? 1. It almost tends to 1. But in this case, the value for f of x, 2.00000000, like that, 1. That is, it almost tends to what? 2. That is, when x, now in this case, when x tends to 1, then f of x tends to 2. So x tends to 1 means x exactly not equal to 1, and f of x tends to 2 means the value for f of x not exactly equal to 2. That is, when x tends to 1, then f of x tends to 2. When x goes nearer and nearer to 1, then f of x goes nearer and nearer to 2. That means, similarly, you can write here, when limit x tends to 1, then x plus 1 will be equal to what? It will be equal to 2. You can put the value for x is equal to 1, 1 plus 1 is equal to 2, but 2 is not the exact value of this limit. 2 is said to be the limiting value of the function f of x. Is that clear to all of you? So this is the concept of limit. Okay. Now let us write down the definition of the limit. So you can copy it. So I think you have understood it. Okay. त तिमीले यो नसारेर तिमीले बुझ्दा मात्रै भइहाल्छ बुझ्यौ छैन अहिले म जुन चाहिँ अहिले फर्मुला डिराइभ गर्छु त्यो फर्मुला चाहिँ एकदमै इम्पोर्टेन्ट हो त्यो चाहिँ याद गर्नुपर्छ बुझ्यौ यो चाहिँ खाली बुझ्दा मात्रै भइहाल्छ ठीक छ त अब म डेफिनेसन लेख्दै छु सो डेफिनेसन अफ लिमिट चाहिँ के हुन्छ त अब व्हाट इज द डेफिनेसन अफ लिमिट नाउ सो नाउ डेफिनेसन अफ लिमिट सो हाउ विल यु रिप्रेजेन्ट लिमिट mathematically that is limit x tends to here it was written 1 so let us write a then f of x is equal to the limiting value of the function f of x when x approaches towards a suppose it is l so यो l लाई चाहिँ हामी के भन्छौं l is said to be a finite limit. Finite limit means defined limit, defined value. L is said to be the finite limit of the function f of x when x approaches a constant quantity a from either side, either from the left hand side or from the right hand side. Okay, so you can write here definition of limit. So whenever you are asked to write down the definition of the limit, first of all you have to write down the mathematical notation, that is limit x tends to a, f of x is equal to l. Okay, so now you have to write down the definition. L is said to be the definite limit or definite limiting. L is said to be the definite limiting value. L is said to be the definite limiting value of the function f of x when x tends to a, or you can write when x approaches a. When x tends to a constant quantity, when x tends to a constant quantity a. So L is said to be the definite limiting value of the function f of x when x tends to a constant quantity a. So this is the concept of the limit. So I think you have understood the concept of the limit. Okay, so now write. So now we will do standard limits now. So let us write down the standard limits. So these standard limits you have already done it in class 11. So again I am revising it, okay, because you should know this standard limits in class 12 also. So standard limit number 1 is limit x tends to 0 sin x is equal to 0. Okay, so when limit x tends to 0 sin x, its limiting value is 0. And number 2, limit x tends to 0, limit x tends to 0 cos x is equal to what? 1. Number 3 is limit x tends to 0 sin x by x is equal to 1, right? Number 4 is limit x tends to 0 x to the power n minus a to the power n divided by x minus a is equal to, so its formula is n into a to the power n minus 1. Okay, and then Number 5 will be limit x tends to 0. This is log of 1 plus x base e divided by x, which is equal to 1. Number 6 is limit x tends to 0 e to the power x minus 1 divided by x, which is equal to 1, right? And then next one is number 7. Number 7 is limit x tends to 0 a to the power x minus 1 divided by x is equal to this is your log a base e. So you should know this formula, standard limits. Okay, so while doing problems you should convert that given limit into these standard limits, and you have to get the limiting value of the given function. Okay, now let us prove this. All these limits, these are known as standard limits. Now let us prove it. So number one is, what is number 1 here? Prove that you have to prove limit x tends to 0 sine x is equal to 0. Okay, so when limit x tends to 0, sine x will be equal to 0. That is the limiting value of sine x when x tends to 0 is 0. Okay, so now let us consider a right angle triangle for this standard limit. Okay, so this is A, this is B, and this is C. Suppose this angle is x. Now this x represents an angle, and this angle is in terms of radian. Radian means, you know that it is a circular measure. So there are three types of systems of measurement of angles. Number 1 is known as circular measure, number 2 is known as sexagesimal system, and number 3 is centesimal system. So actually in your syllabus you have only got 2 systems of measurement of angles. One is known as circular measure and the other one is known as the sexagesimal system. You know circular measure, isn't it? What do you mean by circular measure, or in terms of radian, that is pi radian is equal to 180 degree. And in terms of sexagesimal system, what do we write? 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds, isn't it? 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. Is that clear? So now let us consider this right angle triangle ABC, and this angle X is considered. So this is your 90 degree, you know that, isn't it? So now this is angle X, which is in terms of radian. If you consider this angle C as X, the side opposite to this angle AB will be the perpendicular. This AB will be the perpendicular. The longest side will be the hypotenuse, and this BC will be the base. Is that clear? So now you have to prove that limit x tends to 0 sine x is equal to 0. Now what is the formula for sine x in terms of perpendicular base and hypotenuse? You know that some people have Collie Brown here turned permanently black. So sine x is equal to p by h. P by h means perpendicular by hypotenuse. You know that, isn't it? Perpendicular divided by hypotenuse. Therefore sine x is equal to, what is the perpendicular in this case? AB. Perpendicular is AB divided by, which is the hypotenuse? That is your AC. So now let us take the limit now. In this case the limit is given as limit x tends to 0. So when x tends to 0, when x decreases, this perpendicular length also decreases. When x approaches towards 0, then this AB also approaches towards 0, right? When x tends to 0, then AB also tends to what? 0. And this A tends to B, isn't it? This A tends to what? B. this A tends to B, and this AC tends to BC. Then this AC tends to what? This AC tends to BC. Is that clear to all of you? So I think you have understood it. So let us take the limit now. So limit x tends to 0 sine x. Now let us find out the value of this limit. Limit x tends to 0 sine x. Okay. So which is equal to limit x tends to 0. But what is the formula of sine x? It was AB by AC. That is perpendicular by hypotenuse. AB by AC. So which is equal to limit now x tends to 0. So now when limit x tends to 0, what is AB out here? What is AB? AB tends to what? 0. So when x tends to 0, AB tends to what? 0 divided by, and AC tends to what? BC. AC tends to BC. So here BC remains fixed, that is constant. Okay. So 0 divided by BC, 0 divided by any number is always 0. So which is equal to limit x tends to 0. What is 0 by BC? That is your 0, which is equal to 0. So we have proved that limit x tends to 0 sine x is equal to what? That is your 0. Is that clear to all of you? So you can copy it. So we will prove the next standard limit now. So let us prove the second one now. So you can pause the video and you can copy it. Okay. Next, let us prove that number 2. Let us prove that what? Limit x tends to 0 cos x, which is equal to 1. Now let us prove it. Again, with the help of a right angle triangle, you can prove it. This is A, this is B, and this is C. This is 90 degree, and suppose this angle is X. Okay, so angle B is 90 degree. Let us consider the right angle triangle ABC with angle C is equal to X. Is that clear? With angle C is equal to X. So if you consider this angle X, the side AB opposite to this angle considered will be the perpendicular. This will be the base, and this is the hypotenuse. Okay. Now what is the formula for cos X? Cos X is equal to, some people have curly brown hair. That is cos X is equal to, curly brown hair means cos X is equal to B by H. That is base upon hypotenuse. This is your base upon hypotenuse. Okay. So, or this is cos X is equal to, what is the base out here? Base is BC. Base is BC divided by, what is the hypotenuse? That is your AC. BC divided by AC. That is, BC is the base divided by AC is the hypotenuse. That is your B by H. Now, when x tends to 0, when x tends to 0, you know that when x tends to 0, then this A tends to what? B. When x tends to 0, this A tends to B. A tends to B, right? A tends to B. When x becomes 0, this AB also becomes 0. When x is decreasing, this AB is also decreasing. When x approaches towards 0, AB also approaches towards 0. Or A tends to B first, then AB approaches to 0, and this AC approaches towards BC. So here in this case, AB tends to 0 and this AC tends to BC. This AC tends to what? BC, right? Now in the next step, what do we write? Therefore, limit x tends to 0. So let us write cos x here. So which is equal to limit x tends to 0. What is the value for cos x out here? It is BC by AC. So it is BC by AC, which is equal to limit x tends to 0. Now in this case, BC remains fixed. BC remains fixed divided by. Now when x approaches towards 0, when x approaches 0, this AC also approaches to BC, isn't it? So in terms of, or instead of AC, we can write BC, because when x approaches towards 0, then AC tends to BC. So you can write here AC tends to BC. So this BC gets cancelled, that is 1, which is equal to limit x tends to 0. So this is your 1 only. So BC divided by BC is always 1. So this 1 is free from x. This 1 is a constant quantity which is free from x. So you don't have to put the value of the limit out here. So which is equal to 1. So it is also done. That is proved. That is limit x tends to 0 cos x is equal to, what is the value of this limit? That is equal to 1. So is that clear now? So you can pause the video and you can copy it. So I think I've understood it. So let us prove the third one. Now we'll prove the third one. That is, what was the third one? You have to prove that limit x tends to 0 sine x upon x is equal to 1, right? Now number 3, prove that, you have to prove that limit x tends to 0 sine x upon x is equal to 1. So in order to prove this, limit x tends to 0 sine x by x is equal to 1, let us write down the formula for sine x. So actually we haven't done the series of sine x actually. So you should know this formula sine x. So let us write down the formula for sine x. Sine x is a series actually. That is sine x is equal to, his formula is x minus x cubed by 3 plus x to the power 5 by 5 minus x to the power 7 by 7 plus dot dot dot, it goes up to infinity. Okay, this is known as sine series. So sine x is equal to, what is the formula for sine x? It is x minus x cubed by 3 plus x to the power 5 by 5 minus x to the power 7 divided by 7 plus dot 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 to infinity. This is known as infinite series because this series has no end. This series has no end, that's why it is known as infinite series. So if the series has got an end, then that series is known as finite series. But if the series does not have any end, then this is known as infinite series. So sine x is known as an infinite series and its formula is sine x is equal to x minus x cubed by 3 plus x to the power 5 by 5 minus x to the power 7 by 7 plus dot dot dot, it goes up to infinity. Okay, so let us prove it now. So LHS is equal to limit x tends to 0, it is sine x upon x, right? So which is equal to limit x tends to 0, it is limit x tends to 0. What is sine x series here? It is x minus x cubed by 3 plus x to the power 5 by 5 minus x to the power 7 by 7 plus dot dot dot, it goes up to infinity. So divided by x. Okay, divided by x, right? So what is common in the numerator? The common is x, right? Is equal to limit x tends to 0, x is taken common here, so within bracket what do we get? 1 minus x square by 3 plus x to the power 4 by 5 minus x to the power 6 by 7 plus dot dot dot, it goes up to infinity, this whole divided by x. Okay, so here xx gets cancels, you know that. Okay, so I think you have understood it. So you can copy it, you can pause the video and you can copy it. Now in the next step, so which is equal to, what are the remaining terms now? Limit x tends to 0, so within bracket what do we have? 1 minus x square by 3 plus x to the power 4 by 5, then comes minus x to the power 6 by 7 plus dot dot dot, it goes up to infinity. All the terms after the second term will be the term containing x. Okay, now we can put x is equal to 0. Actually it is x is approaching towards 0, but in this case you have to get the limiting value. So x is approaching towards 0, so instead of x what can you write? We can put 0 out there. So is equal to 1 is a constant term, it remains as it is. 1 minus, if we put x is equal to 0 here, it is 0 square by 3 plus 0 whole to the power 4 divided by 5 minus 0 whole to the power 6 divided by 7, it goes up to infinity. That means after this second term all the terms will contain x, and that is, what is the limiting value of x? That is your 0, so you can put x is equal to 0 out there. So which is equal to 1 minus, from this second term all the terms will be 0. So what is 1 minus 0? Which is equal to 1. So it is proved. Okay, that is limit x tends to 0, sin x whole divided by x will be equal to 1. But that 1 is not the exact value of sin x by x when limit x tends to 0, but 1 is the limiting value of that limit. Is that clear? So limit x tends to 0, sin x whole divided by x will be equal to 1. So it is proved. So I think you have understood it. Okay, so now this much is for today. So in the next class we will prove the other standard limits. Okay, so you can revise it at home, and you should know all this concept of limit, and you should know all this formula so that we can do some problems. Okay.